Hello, everyone, and welcome to this week's episode of Whether or Not. I am your host, Ryan DePhillips, joined by our forecaster for this week's show, Salix Iverson. So, Salix, we've had quite a bit of a snowy stretch.
We sure have, Ryan, and we also have had some Arctic air, especially with Monday morning's low temperature of 8 degrees, which has been the coldest air we've seen so far this year. I think that this trend of cold and snow will continue into the next week, so stay tuned for the forecast.
Yeah, personally, I don't mind the cold and snow as I'm outside enjoying it by sledding and skiing. But anyway, for this week's episode, we'll be each doing one nature in the news story. So, what will you be covering, Salix?
For my story, I'll be talking about the deadly avalanches out west. How about you, Ryan?
I'll be doing a story on a new discovery about how scientists overestimated the cooling effect on marine clouds. We also have an in-depth feature from our very own Michael Jablonski on lake effect snow.
But first, here is Nature in the News. According to the National Avalanche Center, 15 people have died in avalanches over the first full week of February in the United States, the most in 1 week since they started recording accidents. This brings the total fatalities since December 2020 to 22 people. Nikki Champion, a forecaster at the Utah Avalanche Center, says that this year's active avalanche season is due to a persistent weak layer of snow and a greater amount of people visiting the West's backcountry. In order to stay safe and avoid becoming stuck in an avalanche, experts suggest that if you are hiking through the backcountry, you should be prepared by having the right gear, such as a shovel, beacon, probe, and a partner. However, the best advice is to simply avoid areas where avalanches might occur. You can determine this by checking the avalanche forecast before you go.
Unique marine cloud trails from ship exhaust have been known to partially offset global warming, but researchers say it's not as much as previously thought. A recent study proves that the cooling effect from these clouds was overestimated by as much as 200%. The way these clouds cool the atmosphere in the first place is through a process known as cloud brightening. The brighter the clouds, the thicker the clouds, and the higher capacity for these clouds to reflect the sun's radiation back into space. The reason why these clouds form and thicken is when water vapor acquires aerosol pollutants from ship exhaust to form condensation nuclei, which are essential for cloud formation. However, these nuclei decrease in only a matter of a few hours, thus thinning and eventually dissipating these clouds themselves. Research has shown that this process provides a surprising discovery that warming effects can also be prevalent. While climate engineering proposals of increasing cloud brightness have been taken into account, a lot still needs to be understood about these clouds before scientists can take appropriate action.
Hello, I'm student meteorologist Salix Iverson with your Central PA forecast. We have very cool air in place with high temperatures about 10 degrees below average for this time of year, with even more Arctic air in parts of the central portions of the United States. So I'll talk to you in my extended about when we can expect some cold air here in State College. But let's take a look right now at our surface analysis for this weekend. So Friday we'll have snow off to our east and our south. And then by Saturday, we'll have more widespread rain and snow as we see this low pressure begin to make its way up the East Coast, snow impacting much of the areas north of the Mason-Dixon line, Pennsylvania, Ohio, Indiana, just a few states, name a few, that will be experiencing snow. And as for rain, that will primarily stay to our south, impacting Maryland, Delaware, Virginia, and other states to our south. By Sunday, we'll see this low begin to make its way even farther up the East Coast and eventually move off to sea, bringing way to more snow in much of the northern northeast, places like New York, Massachusetts, and Maine, and giving us here in State College and much of Pennsylvania a very dry weather pattern and conditions for the next few days starting on Sunday. If we want to look at our forecast for this weekend, we'll see a mostly cloudy sky on Friday with a high of 26 degrees. Like I mentioned, that's about 10 degrees below average for this time of year. By Friday night, we'll drop down to 15 degrees, a very chilly overnight low, and a mostly cloudy sky will remain. By Saturday, some chance snow again with a high of 23 degrees, and if we head into Sunday again, maybe some chance flurries, but we should be remaining pretty dry here in State College. Our high a little bit warmer, bumping up to 29 degrees. And now I'll send it over to MJ, who has a feature on lake effect snow.
Lake effect snow, it's a term which most people have probably heard, especially those who have experienced winters in the northeastern US or near the Great Lakes. But how does lake effect snow work? What is its significance? And how are changes to the environment and to our forecasting abilities impacting our understanding of this phenomenon? These are the questions I decided to delve into for this week's feature. Now, in order to properly assess this topic, a basic level of explanation on lake effect snow needs to be given. This process occurs when a cold air mass passes over the Great Lakes. Heat and moisture are collected from the surface, strengthening the system and resulting in above-average snow production for areas near the lakes. This may seem easy to gauge, but tiny differences in wind direction, upper air temperatures, and moisture can make a difference between a town receiving a few inches of snow and a town receiving a few feet of snow. Now, I'm no expert with lake effect snow, so I reached out to one of my fellow students, Quinn Mulhern, who's currently doing research under Dr. Stephen Graybush at Penn State for this very phenomenon. Regarding his work, Quinn frequently stressed the importance of elevated mixing layers, or EMLs, to me.
So we've been focusing on elevated mixed layers, which are typically identified in Midwestern severe weather and warm season convection events. And we have come to realize that these elevated mixed layers are actually present in the Great Lakes region at the time of lake effect events. We realized, okay, so this could have some major implications on operational forecasting. If an EML is present, will it enhance the convection or will it maybe inhibit the convection? So those are the questions that we will still need to answer in our research. But as of now, we've been able to identify these EMLs on each of the 5 Great Lakes many times over the past few years.
One of the topics Quinn and I discussed was how climate change played a role in lake effect snow. I had looked into this a bit beforehand, but I wanted to hear his take on the matter.
Yeah, so I personally am not one that really, I don't understand the entirety of the impacts that climate change may have on lake effect snow, but there are some subtleties that I have noticed, especially over the past few years. And one of the most significant things I've noticed is our warm winters and our lack of ice coverage on the Great Lakes. So if there is a warming trend due to climate change, we can see that there is less ice cover. Like, for example, right now, Lake Erie would normally be at around 50% ice coverage, but currently I think they're only close to maybe 10%. So when you don't have the ice coverage over the lakes because of the warming and we don't have those Arctic air outbreaks like we have seen in the past, the lake effect machine can stay on for the entire winter. As long as you don't have ice covering the lake, you can keep producing these significant lake effect storms as often as you want, as long as you can supply the cold air. So with that being said, if there is a warming trend, you're going to have less ice over the Great Lakes, but you will also not have maybe necessarily the cold air in place to even lead to a lake effect storm.
Indeed, this did go along with the info I had found from the National Climate Assessment, which had stated that its findings were inconclusive as well. Various reports suggested, much like Quinn did, that warmer water temperatures would produce higher snow totals in areas closest to the lakes. However, a lower frequency of snow-producing systems would mean less snowfall for the rest of the Midwest and Northeast. These opposing factors mean that a significant trend couldn't be detected for lake effect snow as a whole. Of course, having all of this info is only valuable if you can apply it, so I asked Quinn how his research, along with other research being done, would help improve forecasters' abilities to assess lake effect snow.
Yeah, so that's a great question, and that's something that we want to take our research to the next step and try and answer that very question that you asked. I do have some beliefs on what elevated mixed layers may do to lake effect. It seems more common than not that because an elevated mixed layer is a layer of reduced static stability that has a cap at its base, that cap, which is a temperature inversion, will often be more effective, I should say, at preventing convection than the layer of reduced static stability is above that at enhancing convection. So I think when these EMLs are present, they may form and they may actually end up shutting off or shutting, at least reducing the strength of the lake effect after they form. However, this is still something we're going to need to look at. But with regards to forecasting, if there is an elevated mixed layer present, we need to determine what that is going to do to the lake effect. And unfortunately, I don't have the exact answer for that right now, but I'm hoping that my research in the future can answer that.
Lake effect snow may only seem relevant for a few months per year for a small portion of the country, but it still plays a crucial role towards how many cities and towns function year-round, or as Quinn puts it.
Obviously, people think of the negative impacts of lake effect snow as being, all right, you're going to have a whole entire highway shut down just for a 5 mile wide band of snow. But there are also some reasons that lake effect is crucial in the way businesses run, especially around the Great Lakes. So really understanding lake effect and its role on society is something that I think needs to be looked into more.
Indeed, the impact of lake effect snow will definitely be a matter to keep an eye on. Reporting for Whether or Not, I'm Michael Jablonski.
Hello, I'm student meteorologist Salix Iverson, back with your extended forecast. So like I mentioned earlier, we may be seeing some of this Arctic air come to our area throughout the week next week. So let's just do a quick weekend recap. So Friday will be mostly cloudy with a high of 26. We'll have some chance snow on Saturday, dropping to a high of 23. By Sunday, Valentine's Day will be warming up. There might be a chance for some flurries, but most of western Pennsylvania and into much of central PA should be remaining mostly dry throughout the day on Sunday. So now let's take a look at our extended forecast for the next week. So we'll see that we'll be very below average for this time of year, average about 36 degrees, and we'll be hovering between the mid-20s to the lower 30s for much of the next week. We'll have mostly cloudy skies on Monday and Tuesday, some clouds move in on Wednesday, and then a chance for some snow by Thursday and Friday. And now let's answer our Weather Whiz quiz question.
And now for the Weather Whiz quiz question. In the US, how many people have died from avalanches during the first full week of February? Is it A, 5 people? Is it B, 10 people? Is it C, 15 people? Or is it D, 20 people?
And the correct answer is C, 15 people. This is an unfortunate trend we have been seeing, as even with increased precautions over the years, deadly avalanches are still a real threat.
Yeah, I agree, Salix. And speaking of avalanches, they can even happen in the eastern US. One destroyed a big part of a ski lodge in Bel Air Mountain, New York this past Christmas, but thankfully, no one was harmed. Well, that's all we have for this week's episode of Whether or Not. I'm Ryan DePhillips.
And I'm Salix Iverson. Have a great weekend.